Level 1, number 4. This one is actually fairly simple, but you have to think about a little, sort of a little substitution. So what we have here is a jet ski, and what we're given is a speed, a constant speed of 12 meters per second. And the only other number is the friction force of 800 newtons in the opposite direction. Remember, friction opposes motion. So if we have this jet ski in the water, we know that the friction is this way, pulling back on it, and then that means that the force of the ski itself, the applied force of the engine, is pushing in this direction. And you could do a very simple F net equation here, and what you would see is that in order for this to be constant speed with no acceleration, this would be a 0, right? And if you look at these two forces, one is in the opposite direction, so it's a negative force. So the friction force, if you call that a negative force because of the opposite direction, and you move it to the other side, it becomes positive, and you get this equation, which basically says that the frictional force must equal the applied force. But you don't really need to do all this in a question like this, because you can infer that. You can just look at the picture and realize that if it's moving at a constant speed and there's no acceleration, the net force must be 0, right? That's Newton's law. And if the net force is 0, then these two forces must oppose each other. So what we now know is the applied force is also going to be 800 newtons. The applied force has to be the same as the friction force. But you can always get it from, doing this F net x if you're not so inclined to reason that out. But that doesn't help us with the problem. Now we have a force and a speed. But work, how much work and power and energy and all of these things, they all require, there's really no V. There's no equation we have that has a V in it. But watch this. Remember that power, because it's asking about the power of the jet ski, power is the amount of work done or the amount of energy used in a certain period of time. So this is an equation we have for power, work over time. Now, we also know that work is equal to force times distance. So we can substitute that into this equation. And when we do that, we get work, take that out of there. We get force times distance over time. Now, look at this part right here. We could break this up. We can break this up into a multiplication that looks like this: force multiplied by distance over time. All we did is sort of pull apart that fraction. If you look at those two fractions, they're identical. And now if you look at this, guess what that is? When you're moving at a constant speed, as this jet ski is, if you have a constant v, then remember d equals vt, and so v equals d divided by t. You just divide both sides by t, which means that what we have here is a v. So the power equals F multiplied by the constant speed. So this little equation is quite handy, but it has limitations. It can only be used when something is moving at a constant speed. So don't ever use this when there's an acceleration. But in this case, this little expression can be used, and now you can see that the power of the jet ski, you just simply use the applied force, which is the 800 newtons, right? Now, it's the friction force in the question, but we've already gone through this reasoning up here to show us that the applied force is also 800 newtons. And we're multiplying that by 12, the speed of the jet ski, 12 meters per second. And that's the trick to this question, is this little substitution. So try that. You can write this formula on your formula sheet as a newly developed formula if you want, but remember, it's very important limitation. It can only be used under conditions